Well, from this unit, when's the only time sides are proportional? If I know what, I better know what to say the sides are in proportion. 17, what do I have to know first? Oh, one job. That's garbage. I was on a roll. 3, what do I have to know to see the sides in proportion? That's only true if the sides are in the same proportion. If, what about the triangles?
The triangles are similar.
Okay. Triangles have to be similar for this to be true, right? So does everyone see? We're going to prove the triangle's similar. Take it one extra step and say the sides are in the same proportion. All good? I still have an issue, though. You're going to tell me I need to prove triangles similar? Guys, I see 3 triangles in that diagram. 3. And I'm not guessing which 2 to pick and prove similar. Is there anything up here that could help us, direct us to where maybe the 2 triangles are going to be? Nick? What's that? Look at the proof statement. Give me the first side length that's listed in the proof statement. CE. Everyone look at CE for me. Is CE a full side in one triangle? What's the triangle? CE? Okay, you found triangle number 1. Keep going. Give me another side that's in the proportion. DE, right? Ooh, DE. Well, I've already got that one. So let's keep going. Give me another one. BE. Is BE a full side in a one triangle? Yep. BE. F. So we found the 2. So now give me angle on those 2. All right. Give me 2 pairs of angles that are congruent. Somebody give me 1 pair. Oh, this fun. Here's the fun starts. 25. 1 pair.
Angle FEB equals CED.
All right. We got these 2, right? Angle CED congruent to angle BEF. I get so fired up. Stop saying reflexive. It's not. 22. Why are they congruent? Come on.
For that. Vertical angles. Sorry.
Yep. Not making a good case for yourself. There's 1A. Where's the other pair then? And you guys haven't even said anything about the givens, by the way. You didn't need the givens to say vertical angles are congruent. Where's another pair? 11.
Angle C is congruent to angle EBF.
You could have also said CDE congruent to EFB, the other 2 angles there. What type of angles did you just give me, Brody?
Alternate interior.
Okay, yes, everyone see the alternate interior? But in step 3, I'm not going to say they're equal because they're not yet. In step 3, I'm not going to say they're equal yet because they're not. Alternate interior angles are not congruent. Only when lines are parallel. Yeah, I need to say lines are parallel first, right? Everyone, midterm review here. Can't say alternate interior angles are congruent unless I have parallel lines. And here is where I saw a huge, what do I want to say? What's the word I'm looking for? Misunderstanding. How about that? A huge misunderstanding on the quizzes and tests when I graded them when I was out is you guys know those are alternate interior, but you don't know the lines that belong to them to say they're parallel. So let me give you a little piece of advice I wish I was here to give you. Just say both are parallel. Both sets are parallel. You can't go wrong, right? If you're debating whether I should put DA parallel to CB or DC parallel to AB, just put them both. Because aren't they both parallel to each other? You can't go wrong. All right, so instead of guessing, just put both pair. But I'm not going to put both pair. I want to put the pair I need. What pair would that be to say Brody's alternate interior angles are congruent? It would be which pair up here? 18. Which pair would I need to say parallel? DC and AB. Yep. Again, if you're going to just make a guess, you might as well put down both pair of the parallelogram. I kind of already gave away the reason, but what's the reason why? 15. Why are these parallel?
Parallel lines apply alternate interiors. Oh no, wait. Sorry. Parallelogram implies opposite sides.
Good. Now I can say they're congruent. So step 4, angle C is congruent to, I can call that angle C, but I can't call that angle B. I got to call it EBF. Little midterm review here. Why? Why are those? What's my reason for that? 24. Ooh. And now you have angle. So now I could say the triangles are similar. Got to say the triangles are similar before you get to the proportion. And unfortunately, you guys just can't copy it from the proof statement. You got to make up your own correct one that matches up the angles. So somebody give me a nice similar statement. 19.
Triangle CED is similar to triangle DEF.
Did I just say congruent a couple seconds ago? All right, nobody noticed anyway. CED similar to, sorry, BEF. Make sure you have the similar symbol, the tilde. Angle. Now the triangles are similar, sides are in proportion. One extra step. No pun intended, but this is similar to what in congruent triangles? CPCTC to say the sides would have been congruent, but now we say the sides are proportional. We say corresponding sides in similar triangles are proportional. CSSTP. CSSTP. Anything? Oh, one doesn't make it great, of course. White. Oh, how about that proof statement? What the heck is that? Huh? What the heck is that? Colons? I believe that's the correct term. Any English studs in here? Colons? Colons? Semicolon, right? What am I asking? 3/4 can also be written as 3 to 4. All this is it's a proportion. Just a different way to write a proportion. If you don't like this, it's the same as saying FC over DB equals AC over PB. Same thing. Same thing. Wow. How about the number of triangles in this diagram? All right, let's help each other find it. Somebody start off. Name a side. Name a side in the proportion. FC. Anybody find a triangle with FC? Yeah, FC. A. All right, give me another side in the proportion. PB. I don't want that color. How about that? PB and D. Yep, PBD. All right, we got them. Wow, I love these givens. So much review here. So much. I got these two sides equal. I throw this random vocab word in, altitude from the old days. Wow. A lot of midterm review here. No reflexive here. Sorry. No reflexive here. Get that out of here. No verts either, huh? No vertical angle. Sorry, get that out of here. All right. Where are a pair of angles up here that you know are congruent? Where are a pair of angles? Do you see any? 16? Who's got 16? Going? Hi, Max. I got these two sides congruent. I got this word altitude. I got this word perpendicular. Got to have something up here.
Angle PDB is congruent to angle AFB.
AF. Because they're both what?
Or because they're both right angles.
Okay, let's talk here. That's a right angle, and that one's a right angle. but I'm not putting both in the same statement like yesterday because they're going to have two different reasons, right? They're going to have two different reasons. So let's start with AFC is a right angle. Angle AFC is a right angle. Why is AFC a right angle? 22, any idea? AFC because?
Definition of altitude.
Oh, yeah, definition of an altitude. Altitude implies right angles. I'll accept anything. All right, now let's go to the other right angle. Different reason, angle PDB. Why is that one a right angle? Oh, 22 again.
Perpendicular lines from 90 degrees.
Yep. That's 3 questions you answered today. You must feel like a real boss back there, right? Yeah, the swag is just dripping off, right? You told me they're right angles. I still don't have an A from angle yet because you still have to tell me. 25? They're congruent to each other. That gives me the first A. Where is the second A going to come from? Where is the second A coming from? I have one pair of angles. Where's the second pair? Come on. Dig it deep. Dig it deep. 22.
All right. Oh, the second pair of angles? Okay.
Okay.
ABC congruent to ACB.
All right. Got it. Angle B is congruent to angle ACF. How do we know that is true? How do we know that is true? 21.
Is it in an isosceles or in a triangle? Congruent sides point to congruent angle.
Across from. Good job. There's a lot in there. Love that. Altitude, being a triangle fact. All right, now we have angle. Give me a good similarity statement about these two triangles. 6. Okay. Oh, you're up next. Don't worry. I'm not going. Now get sweating. Yep. Triangle.
Triangle PDA is similar to
PDA.
Oh, PDB, sorry.
Similar to.
AFC.
Okay. Angle. And now I could say the sides are in proportion. You're not going to have any idea. And I don't care. You want to do the colons? You want to do the traditional proportion? Up to you. Go and impress somebody this weekend with the colons, huh? CSSTP. Wow. Take a little breather here because you're in for it. Next problem. All right, let's do this. They're parallel. We know we don't let that freak us out. That just tells us the triangles are similar. We should have the ability to write a correct proportion. First thing up, give me a side length of the smaller triangle. Go ahead, 12. 4. There we go. Make it nice and easy here first, right? What's the 4 correspond with? Should be nothing you have to add up. 4 corresponds with 14.
X plus 3.
X plus 3, yep. Nice work, everyone. Now let's get a little dirty now. 4 and what's the other side of that triangle? 4 and 7. Thank you. How about 21?
X minus 1.
X minus 1. Now here comes the tough part. What does X minus 1 correspond with, right? Well, X minus 1 is FA. What's FA match up with? FA and 13? C. CF, right? The large one. I can't have partial sides, right? AC is not, you said FC, right?
Yeah.
Okay, I'm just going to leave it at that. CF. The two parts are X minus 1 and 2. I got to add them. So what is the length of CF? 9?
CF
Yeah.
is x 1 plus x.
You ready to multiply now? Cross them up. Nice and easy here. 4x plus 4. Whoa, yeah. X plus 3 times x minus 1, our favorite. Go ahead, double distribute. I'll ask somebody what they got in a minute. Double distribute. Make sure you can do this on your own. Friday's not a group test. Even though that's the only way some of you will see a number in the 90s. And that's by adding all your scores together. Too harsh, some groups. Too harsh. Worst groups in the nation, some groups. Or do I have any best groups in the nation, you think?
Us.
When you're absent? Whoa, too harsh. That first quarter group up here was pretty good. With Ellie, Zach, right? That was a pretty good one. It's all right now. It's all right. You know what I missed a lot, Bridger? You know what I missed a ton? I thought about at least 5 or 6 times when I was out. Was just, I wonder if Bridger's feeding his face with a baguette right now. I wonder. That's what I was wondering when I was home.
They don't have any more baguettes.
Oh, I'm sorry. Yeah, just that day, you're just like a sawmill right in there.
It was a good baguette.
I'm sure it definitely was. I could tell. Oh, Joey Chestnut was eating that thing. 6, x squared. Combine your like terms for me and just give it x squared.
Plus 2x minus 3.
Got it. Thank you. Everyone else all set there? It's just something I don't have time to go over. Now we get it equal to 0, so move the 4x and the 4 over. Let me know what you're left with. X squared. Move the 4x and the 4 over. What's left? 5.
6x minus 1.
How'd you get 6x, Claire? You're better.
Oh,
How do I move the 4x over?
2x.
You're rattled.
Subtract.
It's okay. I subtract 4x over.
Negative 2x.
-2x. There you go.
Minus 7.
There you go. You good? It's all right. You know what I figure it is? It's just sitting too much next to John. Just those vibes coming over. All right. I know you're embarrassed to be there, Claire. I'm sorry. So at this point right now, we'd be like, what? It's time to factor, right? That's what we've been doing the last 2 days. It's time to factor. So everyone's like, all right, here we go. Give me 2 numbers that multiply to -7 and add to -2. Let me know when you get there. So we're not, right? The only numbers that multiply to 7 are 7 and 1, and there's no way you're getting a 2 from that by adding it. So are we all clear? This is unfactorable. You cannot factor it. So the only other way I have to solve it if it's not factorable is quadratic formula. And that's what's going to happen today. I can't factor to find the solution, so I'm going to have to use quadratic formula. Which, again, reminder, I'll give that to you on Friday's test next week. All right, can somebody pluck off the A, B, and C values so I can get rolling? 19, A value,
1.
B,
Negative 2.
C.
Negative 7.
All right, good deal. Time to plug and chug. What do you plug in for negative b then? If my b value is -2, in for negative b is going to go 21. +2, plus or minus. I just want to remind you my feelings from the other day. When you plug in underneath the radical, you put parentheses around it, and parentheses go in your calculator. I taught this lesson period 1 into your period 7 counterparts last period. Nobody has yet to get the number right underneath the radical on the first try. That's why we use parentheses. Okay, let's see if you can do it. On b, so it'll be -2 squared minus 4, parenthesis 1, parenthesis -7, all over 2 times 1. And I tell you that not to scare you of whoever's I'm gonna call on next, but just to tell you, you could get it wrong very easily. Nobody has gotten this right yet on the first shot. X equals 2 plus or minus. What's that number I get underneath here now? All right, got to use parentheses. Before I call on somebody, this year never should be negative. You should never have a negative number underneath the radical, ever. That's for next year, if you make it. All right, that's for next year. Truth hurts, I know some of you right now are like, he's right, he's right. You can never get a negative underneath the radical. All good. If you did, you know you did something wrong. Go back to the calculator and recalculate it. So what number do I get underneath here? Oh, is period 8 going to be the changer today? 20.
I got 4 radical 2.
Why stop being a hero and a superstar? I just want to know the number underneath originally.
32.
Thank you. 32. Bridger. Bringing it home for period 8. All over 2. What's the direction say, though? That's not simplest radical form. That's why we worked on that on Tuesday. 32. Break it down for me, please. 4 is not the biggest perfect square. I hate to break it to you. Keep going up. 4 is not the biggest perfect square. Keep going up. What is the biggest perfect square in the 32? 8. 16 and 2. So that should go to 4 radical 2. That's what I'm substituting in for the 32 now. 2 plus or minus 4 radical 2 over 2. The radical's all right, but the fraction's not simplified. From here, I know we haven't done this in a few days. I break it up into 2 fractions. 2 fractions. I look at the number to the left of the plus or minus and put it over the denominator. I look at the number to the right of the plus or minus and put it over the denominator. Make this 2 fractions so I can reduce easily. All right, help me reduce. 27, 2 over 2. 16. 2 over 2.
1,
Now what's this going to simplify to?
2 radical 2.
No, I didn't box it in yet. I got a problem. And we're going to have this awkward staring contest till somebody figure out what this problem is. I got a problem. We didn't factor, but at the end of the problem, the rule still applies, even though we didn't factor it.
2 answers.
I know, I do.
1 plus 2.
You want me to write them out? I can. That wasn't my issue, but it leads to my issue, though. This is 2 answers, everyone, right? 1 what? Plus 2 radical 2, and 1. Grab your calculators for me. I'll do it with you. Everyone type in 1 minus 2 radical 2 and look at that number. 1 minus 2 radical 2. You guys didn't think about it because my answer wasn't a whole number and I didn't factor, but what's the problem? You plug that in, one of the sides is going to be negative. So even with quadratic formula, I have to worry about rejecting an answer. Even with quadratic formula, I cannot have that as an answer. Gone. So there's only one here. 1 plus 2 radical 2. All right, that was tough to remember that. Because you guys, I know you guys are used to seeing whole numbers, and if one's negative, I'll reject it, but I still got to worry about it with quadratic formula. I'm still not done. Flip it over to your work tonight. Actually, go back to this problem. There's one thing I want to say about this problem before I end that one. Quick secret. Even before we did the... It's not that funny. They're adults, too. That would be even more awkward if I just stared at them. Even before I set up this proportion right here, I knew I was going to have to use quadratic formula. Go back to the directions. How did I know? Everyone see? Is there any time we've ever factored and you got a radical in the parenthesis? No. So you know, watch out for the directions. If I see simplest radical form, it's probably going to be quadratic formula. Flip it over now to the next problem. What's the direction say there? Have you ever factored anything you were left with decimals that you had to round? So probably what are you going to have to use here? Quadratic formula. Okay, and last thing, how are you going to match up the sides? How are you going to match up the sides? How am I going to know what x minus 1 matches up with? The statement. Yes, the similarity statement. Whew. Nice work today. Have a great weekend.